Today, we'll be learning how to collect and analyze data, determine the equation of best fit, make predictions, and solve real-world problems. When solving for curves of best fit, there are four main types of functions: linear, quadratic, cubic, and exponential. So to practice, predict the value at 40 years using an exponential curve of best fit. So this is your data. You have your x values and your y values. You're going to plug all those into the calculator.
So once you get all the data, you're going to go into the calculator and plug it all in using the table. And make sure to put x and y at the top. And press enter after each one, or else it won't work on the graph. Okay, and once you do that, you're going to add another page and go to data and statistics, and it's going to have all your points, and you have to put x at the bottom and y on the side for your graph. And after that, you're going to go to menu, analyze, regression, and you're going to use the exponential one because that's what the equation states, and that gives you the problem. And once you have the problem, you're going to work it out.
After you found your equation, this one's exponential, you're going to plug in 40 for x because you're looking for the value at 40 years. And once you plug that in and work it out, you'll get the final answer of $10,560. The table shows the ages x in years and trunk diameters y of several Texas grapefruit trees. Using a calculator, find the equation of best fit.
Okay, so this one you're finding the curve of best fit. Unlike the last one, you don't have to predict anything.
Using the information that you've learned in previous lessons about the shapes of the different functions, you should be able to determine that this would be a cubic function. So now you'll analyze it for the cubic function, and you should get this. And you can click on it, and if you click and hold it, you can drag it across the screen so you can see the rest of your answer. So your answer should be y equals 0.00211 x cubed minus 0.0766 x squared plus 1.26 x minus 0.0664.
The manager of a restaurant kept a record of the number of Y customers in each hour, where x equals 3 represents 3 o'clock p.m. What is the line of best fit?
For this, you'll have to plug your numbers in. This calculator is a little different than the one we used before, but you're going to want to go to Stat, Edit, and we already have the numbers in here. So we can just go to the graph, and looking at those, you can determine from our past function lesson that this would be a quadratic function, though upside down. So you're going to go back to Stat, Calc, Quadratic Regular, Calculate, and so this would be your equation of best fit.
Break mistake! The 2 is supposed to be negative!
You're right, Steven. 10 extra credit points for you. Final answer will be y equals negative 2.97 x squared plus 40.4 x minus 85.9. Next, we'll be learning about standard deviation and z-scores. Important for this lesson is the z-score formula, which is x minus the mean over standard deviation. And also, standard normal distribution is a normal distribution with a mean that looks like this, 0, and a standard deviation of 1.
Okay, for this problem, the problem reads, the data set for ages of the job applicants was normally distributed. The mean of the ages was 30, and the standard deviation was 3.5. What is the percentages of applicants 21 years or younger?
So you're going to need to plug your information into your formula. So they're looking for 21 years, which will be x, minus the mean, which is 30, over 3.5. And you get approximately negative 2.5 So next, you're going to need to go into your z-score chart and follow your information where you have negative 2.57 and you'll get 0.0051. And so since you're changing to a percentage, you'll move your decimal over 2 places. So you have around 0.5% of the candidates were 21 years or younger.
Weights of boxes of cereal are normally distributed with a mean of 20 ounces and a standard deviation of 0.25 ounces. What is the probability that the box weighs at most 19.4 ounces?
So again, you'll have to plug everything in. X is going to be 19.4 minus the mean, which is 20, over your standard deviation, which is 0.25. And let's see. After plugging that all in, you should get negative 2.4. And if you go to your z-score chart, negative 2.40 will be 0.008.
2.
And because they're asking for probability, you're going to keep it as a decimal. And so that will be your final answer.
Last problem is, a normal distribution has a mean of 64 and a standard deviation of 7. Find the probability that x will be less than 45.
Alright, so just like the last two, you're going to plug in all your values. So your x will be 45 minus the mean, which is 64, over your standard deviation of 7. So when you simplify this, you're going to get z equals negative 2.7. And if you look that up on your z-score chart, negative 2.7, you'll get 0.0035. And again, this is probability, so you'll leave this in a decimal form as well. So this will be your final answer.